Anybody identify what that choice was?
How much testing versus training data?
That one turns out that actually doesn't matter almost at all. I mean, as long as you set it somewhere that's in the neighborhood of anywhere between 10 and 40% for testing, it's kind of fine. And in fact, there was a step that you could have done to get a little bit better after you've already trained your model and found a good set of parameters, good set of variables, was to make the testing data almost zero, and then giving the whole data set to your model to train on. At the very end is the last step. Something that we'll see later on. But there was a data cleaning step that I did in the code that if I hadn't done it this way, you guys would have had much, much worse models.
Is it the creating the mean for the missing data sets for the quantitative variables?
No, that one was not. Well, I might have made. Maybe there's a better choice I could have made for that. I filled in the quantitative variables with the mean. But I filled in the categorical variables with missing. What else could I have done here?
Left it empty?
Can't leave it empty. Data set's got to be filled in to be used by a model, right? You got to fill it in with something. I filled it in with a new category called missing. But what would an alternative have been?
Missing 0 through whatever. Put each missing one in a different category. Because you don't know if you could lump them all together.
Well, so every category, like wheel type, had the missing was distinct from like, a different category that had missing values. Alternatively, I could have filled this in with the most common value. So filling in a continuous value with an average is somewhat analogous to alloy. It turns out alloy is the most common wheel type by a large margin. So if I'm guessing that this number is missing, I could just say, oh, well, I get probably an alloy, right? Most other things are alloy, so I could have filled it in with an alloy. But if I had done that, we would have entirely missed this wheel type relationship, right? Wheel type would have been an irrelevant variable at that point, because we would have gotten rid of the signal that was actually important here. So it turns out that our data cleaning step is an important part of the modeling process as well. That how you clean your data, and I've heard, I think Sam, you were talking about how you guys had a project at work that you got all these different sensors that aren't synced up in time, right? And so like trying to somehow merge this data to get it to work together is hugely important to actually extracting meaning from it, right? Mm-hmm. So this data cleaning, so the choices you make in data cleaning, some of them have right answers. For example, there's a right answer about how you sync up your sensor data, even if it's not necessarily feasible to get there. But some might just have better answers than others. So here I chose to fill in missing. And that gave us a lot more predictive power, even if we're not entirely sure what that predictive power meant. Alternatively, I could have filled it in with the most common. I could have done something else. I could have tried to use all the other features that were not missing to predict what should have been there. That might have been a little better than filling it with alloy, but still would have entirely missed this connection to missing. But I don't have to necessarily rely on knowing exactly what this data means to figure out what is the right answer in my case, because I can try them and see. And so I didn't go into this knowing that wheel type missing was, I went into it today, obviously, knowing wheel type missing is important. The first time I saw this data set, I had no idea wheel type missing was a relevant variable. And I'm guessing that nobody here looked through the variables and were like, wheel type, that's the one I need to put in the model. I suspect almost everybody found this variable because they tried everything and they were surprised when it popped out as the important variable. And so generally speaking, I tend to fill in missing categorical variables with the most common value. So one day I happened to try filling in missing here instead of the most common value, and the model performance jumped up dramatically. Still don't know why. Maybe it matters to how we use it downstream. To Caroline's point, maybe I would insult my buyers if I forced them to use a model that was telling them something too obvious. Maybe they wouldn't care, and it's a big boon to our ability to buy cars. But I couldn't have predicted this a priori. I had to try things out, see what happened in test sets, and to get to an answer like this. Which, same thing you guys did, except you weren't necessarily picking that particular imputation value. I felt a lot about trying to add choices around imputation into this notebook, but I think there's enough choices as it is right now. Okay, thoughts before we wrap up our long session on Carvana?
So is that backward selection a better approach in general?
Not necessarily. I mean, it turns out that in most things in data science, it's hard to say something is better in general, but it's often the case that with complex data sources, particularly when we have lots of data, that letting the data speak for itself instead of applying your own biases too strongly will lead you to surprising things. If instead we had relatively small amounts of data and lots of variables, so it was wide but shallow, and we put in too many things, we would just dramatically overfit and never be able to tell what was the right thing, what was the wrong thing out of that. So we can do this primarily because we have something like 80,000, 90,000 rows in this data set. Which isn't a huge amount, but it's enough for this kind of data that we're looking at. And that's the ethos behind data mining. It's not to abandon all human intuition when you're approaching the data set, but it is to come at it with a perspective that you don't necessarily know what's going to happen, and that you're willing to discover surprising results. Great. Any other comments before we close? Harlan.
You had a question. So in your intro lecture, you talked about 80% of models don't make it to the finish line or something. With the data provided and a high Gini index, is this something that you'd be comfortable with, giving to a buyer, this data or this model?
So in this case, I would want to. There's steps we haven't finished before I want to deploy it. For example, what we're predicting probabilities that something is a bad buy and it's not bad buy. What I want to do if I was Carvana is I'd take this model and I would have to pick a threshold for what I thought was a car I shouldn't buy. Then I'd want to look and see, okay, well, let's look at historical data of cars I bought like that. Let's see, how much money I would have made based on the historical data, given that threshold. And then I'd put it in the hands of a subset of buyers and ask them to test it out, give me user feedback. I build it into the entire system of the car buying experience and test it out as part of the entire system of the car buying experience. If it continued to be economically valuable, meaning that on back testing we made significantly more money, and after running it by other stakeholders, they were willing to and excited about using it, I deploy it. We can't answer all those questions because we're not Carvana. We don't